London on your screen. I know it spins slowly and it's flashing, but one revolution on the real London Eye takes 30 minutes. Let's get into it. Right, right. This is a complex animation. It's a landmark, but there's 6 steps to creating it. Firstly, we are going to add in the support stands. Those are the stands that hold up the London Eye. Secondly, we're going to add in the arms, which are the 32 arms that go from each capsule to the center of the London Eye. Thirdly, we are going to add in the main structure. This is a structure that holds the capsules up and enables them to spin effectively. Number four, we need to number four, we need to add in the capsules themselves. Otherwise it's unrideable and it's not a good Ferris wheel. Number five, we added the spinning mechanism. Or else there's no point in riding this Ferris wheel, and lots of all of them will just be useless. And that's the final step. Extra number six will be we'll go to code this using object orientated programming. So so those are the those are the six steps I said 6 steps to creating it, but it really is 5 steps. But anyways, let's get into it. From turtle import all. Much sim. I know it's more complex import turtle, and it's actually you might think that it's actually a waste of lines, but it's actually a line saver because you don't have to put turtle dot done, uh, turtle turtle dot forward, turtle dot back. You don't have to do all of these, and instead you can just do done, forward, back. Actually, forward 10, back 10, and see if the turtle has moved. So that's why I use from turtle import all instead of having to put turtle dots after every turtle command. From math import all for the same reason I've just explained. Shape circle, just taking advantage of the import all. Done. Taking advantage of from turtle import all instead of import turtle, and as you just saw, there was a circle on the canvas, and then we're now going to draw the support structures. Support one equals turtle, shape equals square, and then we're going to have a second support two, and there we go. You have two squares, one's just overlapping the other, and then supports equals support one, support two. And then for range two, supports I equal speed 0, so that configuration doesn't take forever. Supports I the shape size stretch width equals 30, so that it goes off the screen. Stretch length equals 1, so that it doesn't go. So that it goes off the screen, and it doesn't create anything. And here we've got a big bar. We're going to have this to be moved centered in the circle, and then the other edge will be off the screen, as I said. Uh, supports I dot up, supports I dot forward 300, and there it is. Supports I dot right 90. That's our progress, as you can see. It's attached to the middle. Supports I dot circle minus 370 plus 40 times I. There we go. We have the support stands ready, up and running, ready to support the to support the, the Ferris wheel. Supports I dot hideturtle it just hides the turtle. That means that the circle's still there. But we're going to get it back by just drawing it by stamping. Force I dot stamp. There we go. It's back. Now that step 1 complete. Now step 2 arms. So so class mechanic. Yep, there we go. Class mechanic. That's how object-oriented programming begins. Define init means initialize the object, self, wheel size, and capsule size. We're going to put the capsules inside inside the inside the arms. The self.wheelSize equals wheel size. Self.capsule size equals capsule size. And then self.heading equals 0. Self.arm equals turtle. The second time we take advantage, not the second time, but the fourth time we take advantage of using not having to put turtle dots after it, but turtle shape equals square self dot arm dot shape size so width equals self dot wheel size stretch times 2 stretch len equals 0.05. Now we've got up to the point, and then actually I'm just going to do 0.1 because it doesn't really matter. Mechanic 1 let's say, actually 20 0. There we go. Aha, now we've got an arm. We're going to have 16 of these arms to represent 16 times 2 capsules, and otherwise 32 capsules, which represent 32 London boroughs. So, 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 we, so that's our self.arm.speed 0. There we go. Now we've we we've add arms. We've now have to make them spin. Define turn, self heading, uh, and then self.arm.left heading. Let's say mechanic. Okay. So A equals mechanic. A dot spin. Nope. Turn. Let's say 1 degree. So yeah, that's turn 1 degree. Let's say, and we can actually make an animation out of this. Let's say for while true, A dot turn 1. So this is a fun way to make an animation. As you can see, it's spinning, but it spins far too fast because every revolution of the London Eye should only be taking 30 minutes, just under actually. So that's too fast. And actually we should have 16 of these. So capsules equals for I arrange 16. A equals mechanic 20 0. A dot turn I times 360 divided by 32. There we go. We have 16, and yes, messed something up. All right, there we go. We have successfully drawn the arms of the London Eye. So that's step 2 complete. Now we're on to step 3. Creating the main structure. Step 3, main structure. So we're going to have a new class for the structure for every triangle. So we're going to have 128 triangles objects, which will be defined as a structure. So define initialize self.wheelSize and heading and fineHeading, because here heading is to note the uh, heading is to note the heading is to note the general heading of the whole arm. So here we're going to have 4 triangles attached to this arm, and then the fine heading is just to make sure that the final product looks like a circle and it isn't jagged. It doesn't look ugly. It looks much. We like the look of it. That's what the purpose of these 2 variables are. And self.wheelSize is equal to wheel size. Self.heading is equal to headed. Self.fineHeading is equal to fineHeading. And there we go. Finish the the variables. Self.shift. Ah, yes, we also need the shift. Self.shift is equal to shift. Self.inversion is equals to 0, because what half of these triangles are going to have the pointiest angle pointed towards the center, and the other half are pointed outwards out of the London eye. Version self.structure is equal to turtle, shape equals triangle. So this is just going to be the actual thing itself. Self.structure equals to uh so A equals self.structure wheel size and wheel size headed 0 fine headed, so 0 0 0. Let's see what we have now. No attribute structure. Ah, yes, not self.structure, but A. We yes. You can't see the triangle right now because it's hidden by lots of other shapes. Uh, so let's get back. So let's get back to work. Self.structure, and we're going to continue configuration. Self.structure is equals to uh, dot shape size stretch width equals to 2.1 plus 0.1 times self.shift stretch then equals to 3.6. Don't worry if you don't understand this. This is just to make sure that it actually looks like a London eye, so that it's perfect, because I'm a perfectionist. And here we go. We have a big triangle in the middle, as you can see here. And then self.structure speed 0, so that it's faster. There's no point just running the same thing over and over again. But self.structure fill color white. So here it's white here, and then is we can only get to see the border lines of it, as in the real London eye we can only see border lines. Self.structure left 90, so that it faces upwards. As you can see here, it's now facing to the north. Self.structure up, self.structure forward, self.wheelSize times. Actually, that's just pointless. We don't need to do that. We'll just configure it in. Just configure it in where we are going to set the headings of them. So yeah. Define invert self, because half of them are going to be inverted. But left, half of the triangles are having the direction inverted. Structure dot actually self.inversion is equal to 1. So that's what we're going to. That's how we are going to define inverse shape size stretch width equals 2.1 minus 0.1 times self Shift is all of these settings is just to make sure that it looks perfect. Stretch left equals 3.6. I'll say it, and there we go. We still have the same thing because I've just defined it, but I didn't do anything with it. Yeah. No point in defining something if we're not going to do anything. Heading, self.edit heading, self.x is equals to self.wheelSize times 20.525. These are not arbitrary numbers, these are just to make sure that it looks perfect, as I said for the third time. Self.shift times 0.525. Anything you see for no reason, anything you see that looks like that for no reason, I just to make the eye look perfect. That's the fourth and last time I'm going to say it. Version times 1.05 times self.shift, and then very complex. Sorry about that. Self no cosine of 90 plus edit headed plus 360 times self.fineHeading divided by 64 times and then all of that times pi divided by 180, which is basically converted from degrees to radians. So basically this was just a polar angle coordinate system, which is very complex and very lengthy, breaking all rules of keeping it breaking breaking all rules of the rule of keeping it simple, because the best way to get through life is to keep it simple. Anyways, but here we've finished completing this, and might as well just explain this a bit. But there's nothing much to explain. This is to modify the position of the triangle. Just modifying the radius, the distance away from the center. This is to modify the angle, the coordinate angle, which is determine the angle between the due east and the fin the line segment between the object and the center, the origin. And then self.structure, the set heading 270 200 plus edit headed plus self.heading minus self.inversion times 180. Alright, why did I just run that? Because it's just pointless. And then self.structure go to self.x self. So all complex. All complexes. There we go. And then, of course, we need to define stamp self dot structure dot stamp the hideturtles self dot structure dot hideturtle. Of course, I will just do nothing because the as I was saying, let's add in structures. So we're going to have self dot. So we're going to have self dot structures. Structures is equal to for I range 8 if I is bigger than 3. Self dot structures dot a paired structure with the parameters minus self.wheelSize I minus 4 bracketed iOS 4 times 360 divided by 120 and then minus 4 uh, I minus 4 times 0.55 and then the shift is minus 1. Of course, there we go. If I say 2 is equals to 1, self.structure is I invert else self. Actually, I'll just copy all of this. Or just I and then sorry for the ball. But we just created lots of things in the turtle, which is slowing everything down. So we don't like that. Yes, I failed to turn them. So they just scan it up in the middle. So we're going to have to do something about it. Dot now for self dot structures and then I dot set heading self dot heading. Ah, there we go. Now we finally. Oh no, this is bad. Yes, that's because I forgot to add the heading. Head self dot heading plus equals to heading. There we go. So I've messed up the order of everything, but there we go. We've fixed it. There we go. That feels so good. To be finally created something. Except I forgot to take the pen off the page. Yes. Probably. Yes. Fill color left. Self.structure. There we go. And and there was a point to all of these what the seemingly pointless parameters I'd set. It's just to make it look perfect. I know there's still some slight imperfections that I can't do anything about, but does it matter? Well, there's still an imperfection here. So it might be a bug that I need to fix. So it's because it's okay to make bugs here. Uh, and it's if I yes, it's because here I was meant to set it to 0. It's so it's okay to create bugs coded inside the video. If it's just seemingly perfect, then it's actually what makes a video boring. If it's perfect, then it's boring. If we make lots of bugs, it's interesting. Disagree with me, you can comment that down below to tell me that you disagree, but I'm not going to care. And look, we've finished creating step 3 of creating the London Eye, which is the main structure. Now we're on to step 4, which is adding in the capsules. So step 4, capsules time. So step 4, add in capsules. So we're going to go here. Add in self dot capsule is equals to turtle shape is no, not shape equals to circle self dot capsule dot so self dot capsule dot actually, so there's two. So there's going to be so capsule one and capsule two. So two pairs of capsules on either pole of the arm equals everything. Self dot capsules equals to capsule one, capsule two, and then for I in range two. Self dot capsules I equal dot fill color gray. And I'm actually going to copy and paste this so I don't have to oh, shape size, capsule size, and then the speed 0, the up, left, right, I see forward, self dot wheel size times 22.6. Yes, just to make it perfect, times 1 minus 2 times I, just to mean that either it's 1 first time and it's minus 1 the second time. So that they will appear on opposite ends. Self dot capsules. Actually, I should have just dot, dot forward the right 90. There is actually a pointer turning it right, so that yes, so that it still continues on a circular path. Capsule one's not defined. Ah, yes, because I yes, self dot capsule one, self dot capsule two. Don't make that mistake next time, please. And I've just made the uh yes, shapes. So I've set it to 0. Stretch with stretch length must not be 0. So yeah, I've just set it to 0 so that we just ignore that for the time being. But now it matters. So I've just set it in the same place. That's because it's just overlapping each other, and 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 so that means that we need to turn the capsules as well. Self dot capsules uh self dot capsule one dot circle minus self dot wheel size times 22.6 minus headed. This parameter is to make sure that it goes on the correct circular path. And this minus line to make sure it goes clockwise, anti-clockwise with the majority. Here, circular path. Here, it defines the path. Here, it defines the direction. So I've got capsule 2, circle, self dot wheel size 22.6 minus heading. So that it turns in a different way. And there we go. And oh gosh. Ah yes. It's because I've just put a comma there. And I meant to put, put it's going the wrong way. That's because I put minus heading where I'm supposed to put heading. So now it's going to go anti-clockwise. There we go. Let's just move this aside. Alright. So that you can see this. Right. Now we've got the capsules. We've added the capsules in successfully. So now that's step 4 capsules done. Now we are on to step 5 spinning mechanism. Step 5 spinning mechanism. So the spinning mechanisms. So we've actually pretty much defined the spinning mechanisms and the turning. We've actually pretty much defined this because we needed to have a spinning mechanism pre-coded with it to make sure that the arms and main structure and the capsules are all in the right place. So now, just uh, uh but the spin mechanism needs to be defined by a dot stamp and a dot hide. All the turtles are hidden but still stamped, so that's how we go to animate everything. Uh, while true for a actually Capsules dot append a. Otherwise, it's just there's no point at having this list. So while true, so this is where we're going to make the London Eye, the Ferris wheel spin for a in capsules. A dot turn two. Every rotation, every tick of the rotation will be around 4 seconds. So so three uh, 5 seconds. So 360 times 5 is equals to 1,800. So that I'm going to turn it to one. So that's here. I know it was in the original thing. It's actually spinning faster. Ah yes, I didn't define how to stamp and how to hide. So define stamp a self, then a self dot arm dot stamp. Just stamp it every turtle object that there is. Self dot capsule two dot stamp. And then for I is self dot structures. Self I dot stamp. There we go. And then for hide turtle is for hide it's just as easy. Uh, hide 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 and then hide turtle. Actually, hide is not good enough. Hide turtle and then hide turtle and everything else is boring and it's just like this. But I'll do it anyway. Hide turtle and then it just gives the illusion. It gives off the illusion that it's hides. It's been hidden turtle, but its reality is it's still there. Just it's shadow, as call it, and uh, that's good. We've have London Eye. We're not done yet because we haven't actually made it spin, but let's see. So does it spin? Oh well, it didn't spin. It's probably because it haven't defined how to spin yet. So a dot turn. There, clear screen. Because it's turning, but it isn't displaying that it's been turned. And if I just stamp the turtles after it spun a tick, it will just stamp itself over and over again the same London eye, and then it will just look like a mess because there's multiple London eyes overlapping each other. That can't be good. So shape circle, otherwise clear screen, so that clear screen and all of this other stuff will be cleared as well. So we're going to have a shape circle and we're going to also stamp the shape. Support one dot stamp, support two dot stamp for a in capsules a dot stamp. There we go. And I believe the London Eye project that's step 5 spinning mechanism done, I believe. And now all that's left is just see it if it actually spins. It takes a long time to set up, but that's because it's just the sheer amount of turtles that have to be used just in this canvas. 128 plus 32, 160 plus 69, 176. 176 turtles all in all that have to be configured. And as you can see, it's spinning. One revolution will be complete in 30 minutes. Now, as, as we have used, we have employed object-oriented programming in the 6th step, And so I declare this creation to be done. Please subscribe. Please like. Let's please subscribe. Check out my creations of the spinning wheel and the also maybe my 3D shapes and my colored ones, and that's it. Goodbye. Also leave a comment.